Okay, so our presentation today is going to be on simultaneity. Jinx. So Bryn and I said the word simultaneity at the same time. That is an example of simultaneity, is when two different things occur at the same time. Another example of auditory simultaneity would be if Bryn and I were clapping at the same time versus different times. So how does that whole idea of simultaneity transfer to our visual system? Well, visual simultaneity would be making the distinction between visual cues that are happening at the same time versus different times. I guess that doesn't work. So have you ever wondered how exactly our brain makes that distinction between things that happen at the same time versus different times? And that's what our presentation is going to look at. So how exactly do we study simultaneity? The most common method is called signal detection theory, and that basically just looks at the responses of participants in a simultaneity task as to whether they have the correct response or the incorrect response. So for a correct response, there are two different types. The first would be if a cue is simultaneous, and the participant reported that it was indeed simultaneous. That would be a hit. But if the visual cues are not simultaneous, and they reported that they were not simultaneous, then that would be a correct rejection.
There are also incorrect responses. For example, if a visual stimuli, if they were not simultaneous, and the participant reported that they were, that would be a false alarm. On the other hand, if the stimuli were simultaneous and the participant failed to report so and instead reported that they were not simultaneous, that would be considered a miss.
Did you know that?
We are worse at seeing the difference between things happening at the same time versus things happening at different times when they happened in our right visual field, over there where Rachel is standing, compared to our left visual field.
Now you know. So we kind of wanted to do a visual demonstration of what exactly that concept is. So for example, if you are a participant and you're looking at the fixation point on the screen, and you would have to make the distinction between whether Bryn and I are blinking at the same time or different times. So if you were trying to make that judgment, if the blinking were happening at the same time on the right visual field, like I was blinking, then you would be worse at telling if that was simultaneous or not, versus if Bryn was blinking at the same or different time. And so we kind of wanted to look at why exactly does this poorer acuity in the right visual field happen and not in the left visual field. Research has found two different explanations for that. The first one being that if there are distractors in someone's visual view, then that could account for the poorer acuity in the right visual field. So if Bryn was being a distractor and I was asking you to focus on the fixation point and whether over here this is happening at the same or different times, but Bryn was distracting you, that could account for why the right visual field is not as good at telling that judgment than the left visual field. The other explanation is best described through an example. So if Bryn and I wanted to go to the mall, and there was a bus that left every hour at 2 o'clock. If we wanted to catch that 2 o'clock bus, and Bryn arrived at 1:20 and I arrived at 1:45, then we would get to the bus stop at different times, but still both make the 2 o'clock bus and both get to the mall at the same time. But if Bryn and I arrived at those two different times for a bus that left every half hour, then she would be on one bus and I would be on a different bus. And then we would get to the mall at different times. So we can think of that example in terms of our visual system, in that if two different visual cues arrive at different times, then the left visual field would be like the bus that left every half hour, in that it would be able to better distinguish between stimuli arriving at different times or the same time. Whereas the right visual field would be equivalent to the bus that leaves every hour, where it would be more difficult to tell whether stimuli are arriving at the same or different times.
We are also looking to explore when this right visual field deficit occurs. In other words, where in our visual pathway, where is responsible for why we are worse in our right visual field compared to our left visual field. And a nice way to think about that is comparing our visual system to a guitar that is hooked up to an amplifier through a cord. And in this example, the guitar is like our retina. The cord connecting the guitar to the amplifier is like the nerves running from our retina back into our brain, and the amplifier is our visual cortex. So if you're playing the guitar and no sound is coming out, you would think, well, there's either something wrong with the guitar itself, there might be something wrong with the connection between the guitar and the amplifier, or perhaps the amplifier isn't working. So the same thing with our visual system. Is this deficit from something with the retina, something with the cortex, or something between the retina and the cortex? To study this, researchers had participants do a pre-training test on judging whether stimuli are simultaneous or not. Then they trained the subjects in the simultaneity task in the right visual field, and then they did a post-training test to see whether the participants improved at all. And what they found was the participants did better on judging whether things happen at the same time or at different times after training. They also found that they didn't do better on tasks that they weren't trained on, so some other type of judgment other than simultaneity. And from those results, the experimenters were able to conclude that the right visual field deficit first appears at the decision-making stage. So in relation, going back to the example of the guitar, that would be like something's wrong with the amplifier. So the conclusions that we're hoping you take from this presentation are that we are better at determining whether things happened at the same time versus different times when they occur on our left visual field compared to our right visual field. And even after training, we are still better at seeing whether something is simultaneous or not in our left visual field compared to our right. Thank you very much.
Thank you.
Give that last thank you.